Hello everybody, thanks for joining me once again. We're looking at question 16 on the Fermat paper from 2005, so that's our 11th grade level contest. In the diagram, circles C1 and C2 have center O. The area of the shaded region is... So the area of the shaded region is something called an annulus or ring, and it's very quick to figure out how to calculate the area of an annulus, and it's sort of the same for just about every shaded area problem that they ever give us on these contests. We can realize that it's just a big circle with a small circle cut out. So it's the full area of the big circle minus the full area of the small circle. And you might not know a formula for the area of a ring, but if I knew the radius for one of the circles and then the other circle, it's very quick to see this is pi capital R squared minus pi little r squared. So as long as I can figure out the big R and the little r, we'd be all set. It's the difference of these two circles. So let's take a closer look at our picture. So we have O in here, and they actually gave us some lengths and some tiny little right angle triangles. 1, 1, and then 1, 1. So, if I wanted a little r, well, it would just be right here. So little r squared is 1 squared plus 1 squared, or 2. Well, hey, I need little r squared. I can figure out little r too. It's root 2, but I'm going to square it anyway. Why bother? How about the big one? Well, it's still going to be from O. So here's big R. Now we don't have a right angle triangle. Or do we? So just extend these guys down here. It's a rectangle, so we're going to have a right angle there. We're also going to have ones and ones, so this side here is 2. This side here is 2. So now capital R squared is 2 squared plus 2 squared, 4 plus 4, 8. And again, we could square root and get capital R, but it doesn't matter. So the area is pi 8 minus 2, 6 pi. That's the area of the shaded section. And 6 pi is D. That was a happy little circle question. I like it. Most often, I've really only encountered these sorts of questions mostly on Waterloo contests, but just about every time you do an area of shaded region, the best way to do it is to realize the area of the shaded region as a sum of smaller regions, like break it up into some triangles and squares, or a big region with some other smaller regions taken away. That's almost always how you do these questions. And the area of an annulus is a fantastic example. Big circle, small circle cut out. Okay? So that was question 16. Join me in the next video for question 17, and have yourselves a nice day in the meantime.